Hello, this is the second video of the fifth calculus series for OCR Pure Core Further Mathematics, and we'll be looking at volumes of revolution for solids created by rotation of a curve about the x-axis. In the previous video we introduced the idea of rotating a curve about the x-axis. You may like to imagine a carpenter turning a piece of wood on a lathe and creating that curve and influencing that solid of rotation. So the region between the curve y equals f of x, the x-axis, and the lines x equals a and x equals b is rotated 360 degrees around the x-axis to create the solid shown. You can see that we will form cylindrical discs, which in effect are being summed to the limit by integration. Remember that the volume of a cylindrical disc will be the section area times the width, where the cross-section area is circular, so using pi r squared, where r is actually y, let's just write it as that, and then obviously the width is delta x. So in effect, V is estimated by summing all of those components, all those discs. In the limit, as delta x tends to 0, this is going to be like integrating, and I'll put the pi outside for the moment, y squared delta x, where we would put y, being a function of x, write it in terms of x in order to integrate with respect to delta x. In this example here, we have that f of x equals x cubed, and so you can see that the volume will be the integration of pi x cubed then squared, because it's y squared, between x equals 2 and 3 as shown on the diagram. This would integrate to take the pi out, x to the 7 over 7 between 2 and 3, which again, if we take the 7 out, is 3 to the 7 minus 2 to the 7, which you can do on your calculators, giving you 2059 over 7 pi. It's probably worth keeping the fraction for accuracy. In the next video, we will look at the volumes of revolution for solids created by rotation around the y-axis.